everyone. Let's take a quick look at the types of chemical bonding. And the first thing I need you to know is that there's sort of three main categories of bonding that exist, and we're going to add a fourth one in a little bit. But the three main categories you want to have in your head for now are ionic bonding. And we've talked about this a little bit already, in that there's metals and nonmetals that make ionic compounds. And it involves the transfer of electrons. So, sodium and chloride, what happens is sodium becomes sodium plus and chloride becomes chloride minus. One thing that we do is we make what are called Lewis structures, where we use dots to show the number of valence electrons. And so sodium, if you look on the periodic table, has one valence electron, so we put one dot next to it. On the other hand, chlorine has 7, so we put 1, 2, 3, 4, 5, 6, 7. These are our neutral versions. I can't spell today. And then in the ionic compound, the transfer of electrons, the way that we show that is sodium has lost its one electron, so we put Na+. And that electron got transferred to chlorine. And so chloride now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. And chloride is a minus, so we put brackets around it, and we put a negative sign. Right? This is the first step to what are called Lewis structures that we'll look at later. And you'll see in another video that the important part about ionic bonding is that you have a three-dimensional structure of many, many atoms. Metallic bonding is similar to ionic in that there's these 3D structures, but instead of transfer, it's what's called a delocalized sharing. And I will let that video do some more talking of this, but there's similarities and there's differences. And then this word delocalized, that means over a really large space. The third type of bonding, which we've also talked about in class up to this point, is covalent bonding. And remember that that's nonmetals that are involved with that. And there's that word sharing again. Hey, here's a similarity between covalent bonding and metallic bonding. They both involve the sharing of electrons, but the difference is this is what we call localized. So for metals, it's what we call a sea of electrons. The electrons are spread out over a large space. For covalent compounds like water, and we'll talk about why water is represented this way later, the electrons are localized. They live here between the oxygens and the hydrogens. So it's a much more localized regional sharing of electrons than this bigger area. And this is the only one out of these three types of bonding where we use the word molecules. I have a molecule of water, but I don't have a molecule of sodium or cobalt, right? We never use that word. I don't have a molecule of sodium chloride. Why? 3D structure. Things that have big 3D structures can't be called molecules because molecules are individual bonded units. So that makes a difference. Again, these three major types of bonding. Now, here's the part where it gets fun. The thing about bonding is that it's not as cut and dried as absolutely metallic or absolutely ionic or absolutely covalent. There's a continuum. And so you have sort of certain compounds that we would describe as pure covalent compounds, things like Cl2. You have other things that you would describe as purely metallic. So sodium, the bonds in sodium are purely metallic. The bonds in sodium chloride are purely ionic. On the other hand, there's some things where it gets kind of fuzzy. Aluminum trichloride. In fact, you hear that I'm naming it funny. Aluminum trichloride, you should be saying, hey, Dr. Davis, that's aluminum chloride. That's an ionic compound. Why are you doing that? It's because aluminum chloride lives in the middle of the continuum between ionic and covalent. The bonds are somewhat ionic and somewhat covalent. Silicon, right? This is a metalloid. If you think about the stair-step line on the periodic table, it's not quite a metal, it's not quite a non-metal. And so it's kind of sensible that its bonds are partway between metallic and covalent. And similarly, there's things that are along the spectrum between metallic and ionic. So I want you to have these three major types of bonding: ionic, metallic, covalent in your heads. But I also need you to understand that in certain cases, there's this continuum. So you pick the best one out of the three categories, but know that chemicals don't always follow your rules or ask your permission. So know that when they act weird, it's because this continuum exists.